Fire in the hole. Welcome to Fro-Dog Arcade Repair. Today on the bench we have a Neotec NT-2501. This unit was sent in to me for repair. The backstory on it is that the flyback was arced into the chassis, the HOT was shorted, there was a blown film capacitor over in the horizontal section, and the owner of the chassis went ahead and replaced the flyback, the HOT, some film caps, and did a cap kit, but the unit keeps going into shutdown as the complaint. So let's dive into it here and get my customer tag off the unit. And as always, we'll start with a visual inspection. Let's start with our remote board. Do we have any broken, cracked pots? Because those would potentially cause horizontal problems, especially if it was a horizontal related cracked pot. This board does not look like it's been reflowed, but I also don't see any really scary looking connections. The pots look like they've all been centered for the most part already. Alright, I think we put our remote board off to the side. You can see our new HOT. It's an FJL 6920. That's a decent upgrade. Let's look at our other pots here on the board. Everything looks pretty well centered. Our shutoff pot's back here. We'll want to take a closer look at that. A couple of the capacitors could be seated down in the board a little better, and you know me, I'm kind of a soldering snob and a glue cleaning snob. So I'll probably attend to that before it's all over, but let's find root cause failure first. Looking at the top of the board, let's look down in here. Alright, we can see some film caps sitting a little high here. They've got some magic marker on them. I believe those are the ones that are changed. Now I do see our coil here. Looks like it has the coating coming off or pulled away. I wonder if it was arcing to it. Might have been interesting to see the original flyback, as well as the horizontal width coil. I don't think it's loose on the board, but the top and the adjuster are broke off and gone. But I've seen worse, so that may not affect things, but it's definitely something to keep in mind. Looking through, nothing. Oh, we got a couple of bent over components here. Here's a resistor that's bent over. Let's straighten it up a little bit. Oh, look at this over here. We have another bent over component over here. We have a disc capacitor. It may or may not be shorting to that resistor when its leg bent over, but also looking at how close those connections are, they may just be soldered together beneath anyhow, and it's a non-issue. Let's take a look. We'll get to our bottom board inspection here in a moment. There's a couple things we need to look at, but there's that transformer. Those devices are right up in here. I think those two legs are already joined together, so no smoking gun there, but it is always good to straighten components up. I'll straighten this resistor up a little bit as well. Things do not look disturbed in the power supply section. I think we've got a new filter cap. The glue's broken, and there's none stuck to the cap. Let's look down in here. Now this is down in the flyback area, and not seeing exactly where our crack or our arcing was happening. I'm looking at this, and what I see is a little bit of a discolored yoke plug, and this diode. What is going on with that? The coating is flaking off of the outside a little bit, and it's awfully funky looking around it. I think that diode could be suspect. We'll want to check that out for sure. Looks like we've had a few things maybe clipped onto this resistor here. That's not bad, it's just noticing. One of the other things that I see right out of the gate here, now this would cause vertical collapse, and I have experienced this on others. Cap kits recently for these, this capacitor, I don't see the label next to it, but it's the one right here next to the vertical linearity adjustment. This cap, and then what's been coming in cap kits lately, has been larger than the original, and if you look, it's laying on top of the corner of this pot, and it can rub through the insulation, and if it shorts the corner post of that pot to the outer case of this capacitor, then we'll end up in vertical collapse. Again, it's just something I've seen in recent history, but it not necessarily what we have going on. But that's something to look at as well. Before we get off the main board, let's check out the bottom. You can see where our caps have been done. Looks like we've got a pad there that's maybe got pulled a little bit, and the lead's folded over and soldered to the same pad. So that's a non-issue. This wire here is a trace repair, it looks like. It's on the edge of that capacitor. Looks like the pad pulled and the trace goes right up to here, right where it's supposed to. We'll check that with a meter. This looks like factory mod, kind of glued on there. Flyback's been replaced, HOT's been replaced. Got a little bit of missing pad here, and over at Q401, looks like maybe we had a pulled pad. I want to look at that with a meter as well. It looks pretty close right there. You got a couple of connections that could stand some reflow. This connection over here on P902, which I'm pretty sure goes to our neck board, yes it does, is ringed. It's always good to reflow all of these headers, both on the neck or remote boards and on the main board. So that'll be part of our rework, but again, I don't believe that's going to be causing us a shutdown issue. R524 here. The pad is lifted to clear off the board. I think we should check that out for good connectivity as well. Comes right over to a pin on the flyback. Reflow our yoke headers. And again, here's another P302. They all look good, but should be reflowed. P502, that one, it might be a little suspect, but nothing serious there. Our video header pin is definitely cracked and ringed here on the horizontal line, and those should be reflowed as a matter of course. Red looks like it's half cracked, and this little one here could be reflowed, as well as P402. Alright, so we see we've got some reflow work ahead of us. Before we're all said and done, I'll replace this trace down on the board with some conformal coating, get rid of the wire that could snag on something and get pulled away. It's not the biggest fan of the wires like that, just from a reliability and long-term standpoint. Alright, well, that's what we got going on the bottom of the main board. Now let's take a look at our neck board. Top of the neck board. Does not look like our 3 color pots have, let's see, I gotta go this way to get in frame. We've still got silicone on them. Those haven't been touched. Neither of those, so our drives and cutoffs are untouched. Caps have been replaced. Okay. Neck socket looks good. Color transistors are solid. So are our 3 power resistors. Let's look on the bottom side. Just a little bit of solder work where caps were replaced. Again, we'd reflow these headers like I talked about on the main board, but nothing I'm seeing here is going to put us in shutdown either. So to go into shutdown would tell me that the power supply is probably working, and our problem most likely lays over in the horizontal section, especially since that's where the Sticks and Weenies event happened. Taking a general look here, let's just start at the basics. Fuse. We've got a fuse. Let's check and see if it's any good. If I can get my meter leads unwound from my power cable to my camera, we'll be in good shape. Alright, check our fuse out of circuit. Fuse is good. Fuse is 4 amp 250 volts, so GMA. What does it spec at? 5 amp at 250 volt. Yeah, that's not going to be the end of the world, but it is high value. I'm not that worried at the moment. I'm going to snap it back in. No. Discretion is the better part of valor. Let's take it out. We're going to put a 4 amp in. Everything else looks okay in the power supply section. Having shutdown issues. We'll check with a meter on a couple of things here. Let's get it turned upside down and get our camera straightened back up. There we go. Let's check our HOT. We're in diode check. Again, it looks like it's been replaced with a FJL 6920. We'll have to look at the schematic to see what it's supposed to be. We got junction there, and that should read that way in circuit, I'm pretty sure. So we'll let that go. I think our HOT is okay. So if the HOT is good, our fuse isn't blown, our power supply is probably good. More likely something else sending us into shutdown. Let's take a look here on this wire repair for a trace. Does it? Yes, it does. And it does not appear to be touching anything else next to it. Okay, that's good. This one over here was close, leading into our transformer that feeds our square wave to the HOT. There's a little chunk of stray solder there. Get rid of that. Well, we're not shorted together. That's a good sign. What about diode check? Q401. There's our two junctions. That's good. Let's get back to continuity here. This pad is one that has been lifted, and it seems to be in good shape. That rings out. So does that one. And goes to this little coil here. I know, where is our width coil? Okay, here's our two coils. L402 is not open, which is good. And that is the coil right next to the horizontal width coil. That is the one that has the coating shrinking away on top. Just looked over here at R430. We've got another badly ringed connection over there as well. Where was I? Oh, horizontal width coil. That reads continuity, so that's in good shape. At least, even though the top's broken, we know that it is electrically sound. Whether it's the right microhenries, whether we can adjust it, whether it has any geometry problems, we'll have to look at and deal with that. Where is that other component I saw? Ah, here it is. R524 is this right here. Let's follow the trace over. It has connectivity. So, feeling pretty good about that. I would like to hit a couple of these badly ringed connections. Again, I don't think they're going to cause any shutdown issues, but I want to hit them while I see them. Make sure that we don't have an issue after the fact. I mean, we look for the usual suspects, but see something, solder something, right? Vertical ICs undisturbed. There's more of those headers. Let's just hit them real quick while we're here. Our video input was badly ringed as well. That's one we gotta take care of. Again, this is not all the reflow, this is just some obvious stuff that I saw. Looks like we got another lifted pad right here. These Neotecs have fragile pads. It is not difficult at all to lift a pad doing a cap kit. So definitely throwing no shade at any other tech that's touched this. It's just the nature of these beasts. Input header, here it is. Okay, and this little RGB header here, I think's that jumper on the board, like a 3-wire jumper. .401 here in the back corner. well, back corner in this orientation. Is that truly the back corner? Who knows? Everything's a matter of perspective. Here we go. There's the one that was ringed. The transformer in the switch mode is always a good one to reflow. It oscillates. It truly oscillates and moves at a level we can't see with the naked eye, and it will eat up its solder joints over time, especially these wave flow manufactured boards. Now, that one's probably the most sketch one there. They don't always get the best coat of solder as it is from the wave machine, and then time, heat, and oscillation brings us to bad connections. Any kind of power resistors, power diodes, those are not a bad idea to check. I've got to stop. I could just go ahead and do all the reflow here. That's not what we're trying to accomplish. We're trying to accomplish visibly wrong stuff. And just to make sure that we're as right and tight as we can be, walking into our diag here. What's up with that joint? Nothing now. Nothing else is jumping out as needing drastic attention, so let's quit the reflow. Alright, we wanted to look at that diode over by the power supply. And this is that little fella right here, D501. I want to take it out of circuit and test it no matter what, but let's poke at it with it in circuit. D501. Got a decent junction that way. And we're kind of climbing that way. I would think we ought not see anything the other direction. Let's unsolder it and take it out of circuit and get a little better test on it. And again, it's a matter of that looks physically, cosmetically suspect is why I'm doing this. It's discolored on the board around it. It's just not quite right from a visual standpoint. Yep, and that pad, of course, lifted up a little bit. It's a Neotec, right? There we go. Let's grab it from the other side and see if we can extract it. Like a dentist today, like pulling teeth. Alright, there it is. The board is labeled correctly. Let's see, did any of that goober down here on the board clean up? and straighten these legs back out. Alright, now let's test it out of circuit. Still in diode mode on our meter. Hit junction one way, no junction the other. Alright, that's a good sign. Let's try our little component tester here. See what that may or may not have to say. Unknown or damaged. That's not good. Got it in different holes. So statically testing it, our meter looks like it's statically working, but in our component tester, dynamically it's not working. Oh, I do have it in 3 and 3. Let's put it in 3 and 2 here. Alright, it's a diode. Reverse current 53 nanoamps. Three is the cathode. Let's test it again. .48 nanoamps of reverse current. Alright. I don't know. Again, because it looked a little cooked, I'm suspect to that one. What is D501? Let me grab a print and see what we got. Alright. I printed these off earlier because I knew I'd want them. That's power supply. Here's main chassis. And that R524, D501. Need 500 series stuff. 400s. 400. Here we go. D501 is a BB4T. Alright, we'll have to look that one up. I'm going to see if I've got a diode that specs out for that. And or I might have another 2501. Let me pull the diode out of that and check. I'll be right back. Alright, a quick Google search tells us that the BB4T diode, it specifically references Neotec chassis, is an obsolete diode, and that the modern equivalent is a 1N4007, which is a very common diode. And after a quick trip to the Fro-Dog parts department, we have a 1N4007. Now, let's get our component tester back over here. Let's see what this looks like in the tester. The first thing I see is our little socket there wasn't seated. Let's try that again. Alright, it still has some reverse current. IR is 14 nanoamps. Capacitance is way down at 7 picofarads. The other one was a little higher. I'm going to go ahead. These are cheap and easy. So let's put one in. And I'm sure there was a cheap and easy, like an old girlfriend joke in there or somewhere, but did the lesser part of making it right now. And we've got our first little suspect part there out of the way. All right, now, still not sure what's going on with this coming off. I'm going to pull that coil out and take a better look at it. It's just two legs, right? Got some glue and some crusties and some stuff growing on it. Again, I have seen worse. They're not the best looking coil. I think we've had some heat and arcing over in here that is potentially really baked at some stuff. Let's clean that glue off while we're here. Okay. Look at our coil, see if we can find a fiberglass pen. There's one. I'm going to cut that little piece of plastic off there. These look kind of green and corroded at the base of this. Maybe it's seen moisture. Yeah. Those legs are not in that coil the best, are they? They just kind of sit in the bottom of that ferrite. There we go, L402, just a linearity coil, L0026. Nope, no spec on being able to test it with a LCR meter. So let's put the little feller back in. All right. And of course we end up with a bagel. Why wouldn't we have a bagel? There we go. Okay. I think that's covered our obvious stuff. I think it's time for a light bulb test and see what our power supply is doing. We have ground on the chassis. Let's come back this way just a little bit. Got our ground here. Got our test point there. Got our high voltage anode in our trusty Pac-Man jar, glass mug. No time like the present. Fire in the hole. Ah. We don't have a fuse in there. Let's see. That is supposed to be a 4 amp. And we found a 5 in it. Let's clip our circuit breaker on, go from there. Now, fire in the hole. Power supply's up, got a chirp. We're falling, we chirped, we came back up higher. We're stable at 121.4. I do not hear anything in the anode jar. Does our B plus adjust? Yes, it does. Let's go back to 121.4, about where we found it. All right. I do not hear anything. Okay, I hear some light sizzling in there. Our B plus is dropping, and there it goes into shutdown. I bet that is exactly what customer complaint is. Okay. Well, we know it wasn't D501. That couldn't have hurt. What about our shutdown pot? Let's tweak it just a little bit. We're up. Into shutdown. We're up. Quicker into shutdown. I'm going to grab another meter here and take a look at that shutdown pot. We're going to adjust it to, let's see if memory serves me right. It'll be just a little off center at about 2.1K. But before we do that, we're going to find our deoxit, and we're going to just hit and work the B plus pot, the shutdown pot, those specifically, to make sure we don't have a scratchy pot issue. Alright, back with our deoxit D5 contact cleaner. Put that in my coffee in the morning, it's so good. Let's do the neck, or not the neck board, but the remote board pots. If we actually had an open over here on something like the horizontal hold, that would throw us into shutdown. Okay, so we should have clean pots. Let's try it again. We're still in our jar. Get our prints up out of the way here. Fire in the hole. Power supply is up. Shutdown. All right. With nothing else going on in the power supply, I'm going to bump that up to 125. Fine adjustment works a little better after cleaning that pot. All right. Yeah, we drop into shutdown pretty quick. Alright, this little meter is auto ranging. Let's see if we can see it here. Let's look for about 2.1K on this pot. 2.4, that's not bad. Let's take our shutdown pot down to 2.1K. $2.107K, and we are a little off center on that. That cosmetically looks right to me as well. It's that dropping power supply that kind of gets me. What do we have going on here, boys and girls? Yep, doesn't last real long, does it? Okay. Well, since this all started with sticks and weenies and explosions over here in the high voltage circuit, horizontal high voltage, and our power supply is good and stable, once it's in shutdown and we're no longer producing high voltage, and generally look around with a meter here in this horizontal circuit. We'll do some off-camera poking around. We'll be back. All right, welcome back. This is our NT-2501 that was sent in. Let's talk about some of the things that we did and we found. I have to say this is probably the toughest dog I've had on the bench in a while. Some of the things we found were just general correctives that didn't necessarily have things to do with the problem, but I guess where I'm at is I cannot definitively point to one individual component and say this was bad. I think we had a cumulative, a death of 1,000 cuts, if you will, several little things going on that by themselves would not necessarily have been that big a problem. But when added all up, it was overheating the HOT and throwing this unit into shutdown. Now, just to go back to the beginning, we changed our fuse to the correct rating. I did find our horizontal frequency pot and our horizontal width pot. All the pots were a little scratchy, and also on the remote board, pots were pretty scratchy. I think in general, my new protocol on these Neotecs is going to be every pot gets deoxit, gets wiped good before I get too deep into troubleshooting so that I don't end up with much issue. Now, we had a couple of component things going on where some components were quote unquote damaged, blown up, whatever, that the owner went ahead and did a little bit of work on. Again, the HOT had been replaced with an FJL 6920, which it has been replaced again because of all of the heat cycling and abuse it took in the troubleshooting process. It did finally fail. So it's got a fresh FJL in it. Now, a couple of things that I found was there was a cap right here at C414 that had been replaced, and it was a poly cap, and I put a ceramic disc cap back in. Poly caps and ceramic disc caps react differently from each other at certain frequencies. What I truly believe what we had going on was a horizontal frequency issue, in that the horizontal frequency was not quite right, overdriving the HOT, causing the heat up in the shutdown. Now, what else was going on? At first, I did think that it could be our LA7851, our origin for our sync signals, so I did socket that and tried another chip to no avail. Had the same outputs and the same things going on, and put the original back in. We had the cap here at C417 was originally split case, arcing out the sides of it, that the person who sent the chassis in had already replaced. It was a 600 nanofarad capacitor, which cannot find a replacement 600 nanofarad poly cap. It had been replaced with a 680, which is actually outside the 5%. And I think that was another little layer of discontent for the chassis. And how I remedied that, the closest I could get was taking a 560 nanofarad and a 47 nanofarad, bundling them in parallel here like you see. And that gives us 607, which is within 1.2% of the stated, which is much, much closer to the 600. I also found the disc capacitor here by the width coil at C4, is that 18? Anyhow, right down in here, the in moving it around and in checking the width coil and doing some things, I don't know if I damaged it or if it was damaged from the event, but the back split off of it and I replaced that disc capacitor as well. Our horizontal width coil was, because of just heat soak and cook and whatnot, you can see that our little top area is gone, and it was when I received it, but the bottom area was cracked and this coil was just kind of flopping loose on the top of the tower. So I epoxied that back into place, got that stabilized. And let's see, where else were we? Oh, D501 had some reverse current on it that was a little higher than I'd like to have seen, as well as it also was a little cooked around the edges and had some, like some coating flaking off of it. So the parts that we replaced that I believe were critical to all of this were D501. We got the right value cap in our C417. Yes. Got a disc capacitor back in here instead of a poly cap. Replaced the capacitor over here by the horizontal width coil. Shored up the horizontal width coil with some epoxy on the bottom side, making sure to not glue the core in place. Cleaning and wiping all of the pots with deoxit, reworking the remote board. The other thing that I'm finding on these remote boards is these plugs are tending to have some connection issues, not just solder ring joints, which pretty easily corrected, but you plug them in and you just move them ever so slightly when you're picking them up to turn them, and you're getting flicker in the picture and weird things going on. I ended up shooting deoxit down in the connector itself and in the plug receptacle, and worked them in and out 6-8 times on each of them, and that cleared that up, as well as wiping these pots good with deoxit. Cleared up adjustment issues. I think that's what we had going on in the horizontal circuit to cause us that thermal runaway and just not be right, as well as I ended up adjusting this horizontal frequency pot better. Now we've had a stable picture. It's been burning on the bench for test for a little over 24 hours. It's been rock solid. I've had it on the test pattern generator, and I'll show it to you on the tube. Other things that I did was this capacitor here. Let me see if I can move that wire harness to get it in frame. This capacitor down at C305, I think. It's kind of hard to see under it. But that capacitor was sitting in at about a 45-degree angle, and it was pushed up kind of hard and tight against the case of the heat sink. So what I did was, this little trick that I've done is to do two 90-degree bends in the legs, just pretty much the width of my needle nose pliers. And then if you look at the legs on that, when you put the capacitor back in, it's now sitting further that way. So I replaced that cap and pushed it off of that heat sink so it wasn't bound up for fear of rubbing through the outside coating. I also replaced this capacitor here right next to the vertical linearity pot. Something I've seen from cap kits recently is a diameter problem with this cap, that the one in the cap kit is a slightly larger diameter, and it's a tight fit in here with the vertical linearity pot already, and forcing that larger diameter cap in can cut this outer insulation and short your cap casing right to the corner of that vertical linearity pot. Boom, vertical collapse. Other things I did to this chassis was clean all the glue off. You see no more of that brown hygroscopic glue that is all crispy and funky. We got that out of there. The cap kit was already done when I got it, so again, I only touched a couple of caps that were problematic. On our neck board, we did have a wrong value cap here at C924. It was a 10 microfarad at 250 volt, and it should be a 22 microfarad at 250 volt. And this cap here at C920 is one that, if it's present on your board, replace it. If it is not present on your board when you do the cap kit, leave it out. It was in this board when I got it. I don't know for sure whether or not it was present originally, but the chassis runs fantastically at this point, so I'm going to leave that alone. On the bottom, if you remember, we had that loop of wire that was repairing a trace, and we had some lifted pads on some caps. So I got rid of that loop of wire and did a short piece of frog hair wire, some real thin gauge magnet wire, and bent it in the shape the trace used to be, got it soldered in, and then put the conformal coating over it, UV cured it. you'll see a good little bit of conformal coating here and there, just some little darker green spots, and that has been to tidy up where there was a lifted pad, where maybe some of the green has come off of the factory traces. And we just tidied all of that up to make it look right and tight and clean it up and insulate any place it might have needed insulated. Pulled our B+ cap out, double checked its value. It did look like it had been replaced, and tidied up the solder work there. And we did a good little bit of reflow on the board and a reflow of several things on the neck board. Now, everything is right and tight. Everything is up to Fro-Dog spec on connections, on conformal coating, on trace repair. It had already received a new flyback. These are notorious for bad flybacks. Especially they tend to get dim and or drift on focus. That's one of the failure points on these. But I've got a lot of time in this one, and again, I titled the video "The Death of 1,000 Cuts." A little bit of an exaggeration. I think it was closer to maybe 6 little things that all, in my opinion, cumulatively added up to the symptom that we had. By kind of going through step by step, piece by piece, brick by brick, my citizen, and tidying all of that up, we now have a fantastic picture and functioning NT-2501. So I think the moral of the story is, don't get discouraged. Sometimes you've just got to dig in and stay at it no matter what, and systematically test component by component. I mean, I tested all of the poly caps down in here, did comparison readings between this chassis and another 2501 that I had. The schematic for the 2501 is not correct. It shows this resistor and this resistor at different values than what's physically in the board. Now, having had a unworked, unmolested NT-2501 chassis to start with, I did comparisons, and they had the same values that was in that other 2501 chassis. Had I just gone with the schematic, I would have thought they'd been replaced and had got wrong values in there. It's incorrect. So sometimes you've got to not always trust the schematic. And the Neotec seemed to fall into that category. They kind of gave one schematic for all the leach-ins and not a lot of great documentation on what they ultimately, I'm going to put a check mark on this since I checked it, ultimately is not right on the schematic. So there we have it. I got 12-14 hours plus. I didn't track it accurately, so I think that's a little light, but I persevered, and this one did not defeat me. So I've got things wire tied and tidied up. I like to put a tie pad back here for strain relief. That way we don't overflex our remote board wires. Those are the words I'm looking for. So let's take it over, put it on a tube, and look at that beautiful picture. And there it is. Got nice color bars. Now you can see that quick bar zooming through the video. That is the frequency picked up by the camera. Since this is high res, you'll notice, or excuse me, medium resolution, you'll notice that it runs a little faster than the CGA stuff on standard res. Good color representation. Red or green or blue. Got a nice white. Grayscale present. Decent geometry. The tube itself, not the best on convergence. Just haven't fooled with that. And then our animation. Now, because it's dark in here, the camera's kind of close. That animation does look like it streaks a little bit. On the screen, it does not. It's just kind of how fast that image is moving. But there we have it. The Death by 1,000 Cuts chassis, Fro-Dog fixed. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends. And remember, fire in the hole.